Hello, welcome back to Learn Physics. In today's topic, we are going to discuss about some of the numericals. So most of these numericals are based on the previous year's question paper. Okay, so this is from the chapter atoms. Okay, so last video most of you would have watched, I guess, because it is a quick revision of atoms chapter. So which are the formulas that is important, all those things we discussed, isn't it? So here in this first question is, in Rutherford experiment, distance of closest approach of alpha particle is d0. If alpha particle is replaced by a proton, how much kinetic energy in comparison to alpha particle will it require to have some same distance of closest approach? Okay, so that is the question. How we can find out the kinetic energy? How much kinetic energy is required to get the same distance of closest approach? Remembering, right, what is meant by distance of closest approach? The alpha particle will be approaching the nucleus at that time, which is the minimum distance where it is getting that potential energy is converting. That minimum distance means that will be this distance, d0. So we are going to find out that. So d0 should be same. Instead of alpha particle, we are using a proton. Alpha means it is He24, isn't it? The proton is 1H1. So how much kinetic energy in comparison with alpha particle will it require? How much more kinetic energy is required for more or less kinetic energy is required in the case of this distance of closest approach. So in the case of alpha particle and the proton. So here first we need the equation for kinetic energy. So what is the equation for kinetic energy? Ek equals 1 by 4 pi epsilon 0 charge Q1 Q2 divided by R. Okay, so here what is the for kinetic energy for alpha particle? If I am writing 1 by 4 pi epsilon 0 into what is Ze, isn't it? Ze into what is Ze? See, we don't know to which atom we are approaching, isn't it? Ze into E square. So 2E. He24, so 2E by R. Here kinetic energy of proton equals, what is kinetic energy? 1 by 4 pi epsilon 0 into Ze is the charge of the other electron which is incidenting on the electron, that is into what is 1H1, so 1 electron by R. So now we are going to compare Ek of alpha divided by Ek of proton. So while we are dividing, 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 cancel, Ze cancel, 1E will get cancelled, R will get cancelled. So we will get 2. So alpha particle is, so we need to how much kinetic energy in comparison to alpha particle required to have the same distance of closest approach. So R is same. So instead of R, if you want, we can substitute D0 because in a question it is given as D0. Okay, so D0 is same. So it is, so we need the EKP, kinetic energy of proton, that is equal to what is kinetic energy of alpha particle divided by 2. Okay, this is how we will be finding out this answer. Clear? So the next is, what is the ratio of orbits corresponding to first excited to ground state in hydrogen atom? First excited state to hydrogen atom. What is the ratio of orbits? That means orbital distance what is the ratio of radii of orbits corresponding to first excited state to ground state in hydrogen atom? So what is the ratio of radii of orbits? So we need the radii of orbit in hydrogen atom. So we know what is the formula for nth orbit. Rn is equal to n square h square epsilon 0 divided by pi m e square. Okay, first excited state to ground state. So if it is first excited state, when I was explaining that one, I told you what is first excited state. First excited state means n is equal to 2. Remembering, right? Ground level n is equal to 1. First excited state n is equal to 2. So n is equal to 2, and in the ground state n is equal to 1. So you can write it as, what is the ratio of first excited state to, so R2 divided by R1. So what will be that one? N square is proportional to n square, isn't it? So 2 square divided by 1. So that will be 4:1. Okay, ratio. So this formula you should know. Okay, so clear now? So the next one is, find the ratio of energies of proton produced due to transition of electron from hydrogen from second permitted level to first permitted level. Second question is highest permitted level to first level. Okay, so we need to find out the ratio of energies of proton produced due to transition of electron of hydrogen. So hydrogen is transiting from first permitted level to second permitted level. Okay, which is the first permitted level? Ground state, n is equal to 1. N is equal to 2 is the second permitted level. So while it is transferring like that, what is the energy transition of photon? Transition energy of photon, that one we should find out. Okay, so the first one is second permitted level to first permitted level. So n is equal to 2 to n is equal to 1. Okay, what is the formula for finding out the energy of transition from n is equal to 2 to 1? What is the formula? RHC into 1 by nf square minus 1 by ni square. Okay, this is the formula. RHC into, what is final? It is coming to first one, isn't it? From the second level. So if you are calculating, you will get it as 4 minus 1 divided by 4 into RHC. So you will get it as 3 by 4 of RHC. This will be the value. Then next is transition from highest to first, which is the highest energy level. So second one, highest permitted level is n is equal to, yes, final is highest to first one. So final is n is equal to 1. Initial is highest, infinity. It can go till infinity. So how this equation will be changing? E is equal to, yes, highest to infinity to 1. So in this case, RHC into 1 by nf square is 1 square minus 1 by infinity. So you will get it as RHC. So understood? This is n is equal to 2 to 1 means this is nf, this is nf, this is ni. Okay. So here what is the ratio then? E1 divided by E2, that is equal to, first one is 3 by 4 RHC divided by RHC. So you will get the answer as 3 by 4. So this formula you should remember. Otherwise the other formula n square, there is r instead of r, you can substitute the values also. Okay. So clear now? RHC into 1 by nf square minus 1 by ni square. Okay. Clear? Easy, right? Okay. Shall we move to the next question? So the next one is, The radius of the innermost electron orbit of hydrogen is 5.1 into 10 to the power minus 11 meter. What is the radius of orbit at the second excited state? So how we can find out this one? The radius of innermost electron orbit of hydrogen atom. That means first orbit. That is, it is given the Bohr radius. That is given as 5.1 into 10 to the power minus 11 meter. So what we should find out? Rn of second excited state. N is the second excited state. So Rn we should find out, but we need to know what is N, isn't it? Second excited state means N is equal to 3. Don't forget, if it is second excited state, first one is ground state, N is equal to 1. Second one is first excited status, N is equal to 2. Second excited status, N is equal to 3. Don't forget that. So N is equal to 3. So we need to find out R3. So what is the relation connecting Rn and A0? Rn is equal to N square A0. Remembering, right, in the quick revision I mentioned it very clearly. So N square into A0. So what is N square? 9 into 5.1 into 10 to the power minus 11. So you will get it as 45.9 into 10 to the power minus 11 meter. Okay, clear now? So the next one is, how would the ionization energy change when an electron in hydrogen atom is replaced by a particle of mass 200 times more than that of electron which is having same charge? Okay, so it is having, mass is increasing. Mass, just we are increasing the mass. So at that time, what will be the ionization energy change? Okay, energy of nth orbit, how we can find out? M e to the power 4 divided by 8 epsilon 0 square n square h square. That is energy of nth orbit. M e to the power 4 divided by 8 epsilon 0 square n square h square. That is energy of nth orbit. So here mass, how it is varying with the, see, how would the ionization energy change when an electron in hydrogen atom is replaced by a particle of mass 200 times than that of electron? See, we are replacing the mass of the electron. Yes, we are replacing a particle when an electron than that of electron. Say, what is the mass of electron? We are just increasing the 200 m. Instead of m, we are giving 200 m. So the kinetic energy, how it will be increasing? 200 times the initial value. So actually it is very easy question if you know the formula. So how the relation is? Okay, that one you should understand and write down. Okay. Next is, which transition belong to Lyman and Balmer series? Calculate ratio of shortest wavelength of Lyman and Balmer series spectra. Okay, so we should find out which one belong to Lyman series. See, so n is equal to 1. That is Lyman series. Balmer means n is equal to 2. Okay, so which is coming to the first level? N is equal to, this is n is equal to 1, n is equal to 2, and 3, n is 4. Okay, so which and all are coming to n is equal to 1? Yes, C and E belongs to Lyman series. Okay, and which and all are belonging to Balmer series? N is Balmer means which is coming to n is equal to 2. So which are coming to Balmer series? B and D. B and D corresponds to Balmer series. Okay, so this is, while seeing all these big diagrams and all, don't get panic. That questions will be very easy. Okay, so that one you should understand. Just read once or twice, you will get the answer if you know the concept. Okay, C and E are Lyman series when it is coming to the n is equal to 1, and B and D are Balmer series when it is coming to n is equal to 2. Okay, now calculate the ratio of shortest wavelength. Calculate the ratio of shortest wavelength of Lyman and Balmer series of spectra. So in this spectra, which is the shortest wavelength? Shortest wavelength, how we can find out? E is equal to h nu. That formula we know. Hc by lambda. So if lambda equals hc by E. Okay, so this is change in energy as equal to Ei minus Ef will be equal to h nu, that is integral h nu, hc by lambda, each photon it is emitting, that one Bohr's third postulate. Okay, lambda is equal to hc by E. If we need to get shorter wavelength, energy should be greater. When energy will be greater? Maximum transition from higher to lower level, then it will be maximum energy will be released. So here in the case of Lyman series, which will be the maximum transition? See, n is equal to 4 to 10. So what is delta E here in delta E of C? What is delta E of C? Delta E of C will be equal to what is energy and 0 minus 10. So we are getting it as 10 electron volt. And in Balmer series, which is the greater transition in Balmer series? 0 to n is equal to 2. So delta E of B is the bigger transition, isn't it? So it is 0 minus, what is this? Minus 3. So we are getting it as 3 electron volt. Okay, so we should find out ratio of shortest wavelength of, not energy, wavelength only it is asked. So we can find out, how we can find out wavelength here? hc divided by 10. Here it will be hc divided by 3. Now we should take the ratio. So lambda L by lambda B. Lambda B will be equal to hc and hc will cancel. So 1 by 10 divided by 1 by 3. So it will be, you will get it as 3 by 10. Clear now? This is the next one is, when an electron in hydrogen atom jumps from third excited state to ground state, how would de Broglie wavelength with electron change? When an electron in hydrogen atom jumps from an third excited state, that means n is equal to 4 to ground state, n is equal to 1. Then how would the de Broglie wavelength of electron change? De Broglie wavelength, what is the formula? Lambda is equal to h by p. So how we can find out this de Broglie wavelength, how it will be changing? Lambda, we don't have anything, but n is equal to 4, n is equal to 1 is there. So what we can find out from n is equal to, so what is the energy required we can find out, isn't it? Kinetic energy of the electron will be minus of the total energy, isn't it? So it will be minus 13.6 divided by n, minus of 13.6 n square, that will be equal to plus 13.6 n square. We know that lambda equals h by p. What is p? I'll tell you. What is kinetic energy? Half mv square. Okay. So if I am multiplying and dividing with m, it will be m square v square divided by 2m. What is this m square v square? mv is p. So p square divided by 2m. So we can write it as p is equal to root of 2m into kinetic energy. So lambda, how I can write? H by root of 2m into k, that is lambda. Okay, now we are coming to the equation. Okay, so when an electron in hydrogen atom jumps from n is equal to 4 to n is equal to 1, how would the de Broglie wavelength will change? Now we got an equation for lambda, isn't it? So lambda of 4 to lambda of 1 we should find out. Okay, h by root 2mk is the formula for lambda. So h by root 2mk of 4 divided by lambda 1. Take the reciprocal and multiply. So root 2m k1 divided by h. Root 2m will get cancelled. Root of k1 divided by k4. Okay, so what is the kinetic energy of the electron when it is in 4th orbit and 1st orbit? We should find out. K1 how we can find out? 13.6 only by n square. K4 means 13.6 divided by 16 you should find out. Then take the ratio. Okay, so 13.6 divided by 13.6 divided by 16, that is into 16. So it will be cancelling. So you will get it as 4. So understood how we will be finding out the ratio of wavelength. So for this, when an electron in hydrogen atom jumps from n is equal to 4 to n is equal to 1. How the de Broglie wavelength will? Don't get panic while seeing the question. So how, see, the known formulas only we should use. Okay, here n is equal to 4 to n is equal to 1. So we wrote it as de Broglie wavelength. What is the formula and in which and all ways we can change. So here you should understand that kinetic energy is minus of total energy. 13.6 divided by n square. Substituting and finding out the answer. Okay, so understood all those things. So I hope all of you understood all those things and it's clear, isn't it? Easy only. So, but how we will be executing the things. How we will be executing the things. That is the only trick in doing the numericals. Okay, so these are some of the previous year's questions. Okay, so we will be discussing the rest of the things in later sessions. First, we will finish the theory portion and then we will continue with our previous year's questions. Okay, so hope all of you understood. Please don't forget to subscribe my channel. So thank you for watching. Bye.